Right, pause button. Pause button. Pause button. Oh, did a whole thing. I'll do that. Eight. What's the answer, Mr. Cassini?
I got y equals 1/5 cosine 5 theta.
Anybody disagree? Looks good to me. Questions, thoughts? Just 5 theta. 1/5 was 1/5 y theta. That sounds, yep. 1/5 cosine 5 theta. Piece of cake, right? All good? Wondering what could happen next? Yes, sir. Be right back there. Oh, hold on. Let me pause. Equals, right? Did it again. It's a y equals, isn't it? So it's going to go up or down. It's going to be a standard, normal, everyday, boring graph. So if it's plus h, it goes up. So if it's plus 3, it goes up 3. If it's minus 3, it goes down 3. Make sense? Good. Now for the bad news. I got 2 bits of bad news. First thing is I'm gonna give you a letter you've never seen before. For the people in the back, they can't see because they don't have their glasses. Looks like that.
Okay.
We call that a phi, as in phi, phi, fo, fum, phi. Now, what is phi going to do to us, Miss Theo? You're going to get it wrong, but you're going to get it mostly right. Please give me the mostly right answer. It's inside the parentheses. What does it do when it's inside the parentheses? What does K do? What'd you say? Okay, if it's inside the parentheses next to the x, it means it's going to shift it left, right, opposite of the way we expect. That's the normal way that happens. Is that okay? That's our normal way of looking at it. Now, unfortunately, because it's a wave, and because this is sitting here, it's going to mess that up. If omega is just 1 or it's not there, it just shifts left, right the way you'd expect. But if it's there, when you shift the graph a certain distance, it's going to mess things up because the curve is going through faster, so it's not going to set right. So that's being modified by this little letter right here. So what we call the phase shift, which is our left-right shift, also expect, can be written as negative phi over omega. And that is how far it's shifted left to right. Because if we put the negative in there, it goes the way we expect. Is that okay, Miss Manship? Yeah. Is that okay? And that's the last transformation we have to worry about. And then after that, it's just graphing. Sine, cosine, and then we start worrying about other graphs. Good so far? All right, let's do an example problem. Me and Ms. Krolik? Yep. All right. I'm going to do the example problem, but I'm going to change it out because it's a dumb one. So I'm making up my own. Visible, what color? Just. Oh, I never should use green. Whatever I'm doing. Okay, so we're going to do y equals. We're just going to do the parts we care about for this new thing. So we're going to do sine. I'm going to do 2 theta plus pi. Is that okay with you? All right. I'm going to set this graph paper up. Oh, no. Plus, I've got to do a plus something. How do you want it to go? 2? Let's make it 2. Oh, I got 2 here. Let's make it 1. I lied. Okay, so I'm going to go pi, 2 pi, negative pi. I'm going to go 1, 2, 3, negative 1, negative 2, negative 3. So far, so good? All right. What's my parent function?
The 2 favorite pi.
Although it looks like it, doesn't it? It's actually not. It's just sine theta.
Okay.
So the answer to that question is going to be sine or cosine, right? That's our basic graph we're graphing here. Okay, then starting from left to right, I got nothing weird. No flippage, no amplitude. That's supposed to be there. This is the first thing I run into that's troubling. What is that going to tell me to do?
That's how how much wait. How how much it's gonna go that's gonna take for it to get to it going.
Another so it repeats, right?
Yeah.
Then how long it takes for it? You did it with your finger.
Yeah.
Okay, so we're going to do how long it takes till it repeats. That's going to be period equals 2 pi over 2. That's our formula. And in this case, I'm going to get pi. I made that small on purpose on accident. Sorry. All right, you should sit in the front. It's only like one period. I only get to see you one time every 3 months. If I read the schedule correctly, which is probably not reading right. Okay, now what do I do with that pi? That's the new formula. The new formula is phase shift, which I'm just going to do PS, equal to negative phi over omega.
Okay, so negative pi over 2.
Pi over 2. Love it. Of course, I'm writing right where I'm going to probably have my graph, but okay. I'm going to go down here in the corner. What does this plus 1 tell me to do?
Goes
Up
up 1.
1. All right, now I'm just going to follow orders. Starting with sine, what does a sine normally look like?
It starts at 0.
Starts at 0. Good?
Yeah.
Okay. Now, next thing, I'm going to make that whole thing happen by pi. That's what the period says, right?
Yes.
So how's that change my graph?
At pi, it'll be. Wait, no, it finishes at pi?
It finishes at pi, right?
Yeah.
So I got to go up. Oh, that's terrible. I got to use dashed line so it doesn't get in trouble later. Up, down, like that. So far, so good?
Yeah.
Okay. Then the next thing, I'm going to phase shift it, negative pi over 2. So I'm going to move it.
To the left.
So I'm going to pick up the whole graph, walk over pi over 2, which is right here, and drop it. Okay? So here we go. It's going to start here. It goes up, down, back to here.
Which part?
Oh, I should still be dashing. That's the phase shift.
So that's just where you started. You started at negative.
So I take this part.
Yeah.
See, here's my curve, right? I'm just going to pick it up, drop it, pi over 2 to the left. Okay? I forgot about the little one we wrote down there.
Oh, and then it has to be up 1.
Up 1. So I'm going to lift the whole thing up 1. So that point's there, that point's there, that point's there, that point's there, that point's there. So now we're leaving our comfort of staying on the x-axis, right? We're going to go up here. How do I fill in the rest of the graph?
You just keep going.
Keep going.
Roseland,
Yes, sir.
I thought a negative would make it go right.
That's true. And this is where you were taught something different last year, so I'm trying to go your way. You were taught that when you write a phase shift, you would write it with the negative in there. Right? It's positive, so I think it should go to the right. But by making it negative, it goes to the left. So I'm putting the negative in explicitly, which means we now follow this. If we use this formula, it goes the way we expect it to go. Because I put a negative in the formula. And I was told that's the way you did it last year, so I'm trying to be good. But I may mess that up before it's over. Also, by the way, the ACT and SAT people, they assume you're going to put a minus there. So that's another reason I do it the way Miss Dumble does it. Good? Frowny face.
Yeah.
Where's Ryan?
Yeah,
What do you got?
I don't know.
It's just kind of weird for starting out, but you can get the next one. Need a little practice. Fortunately, I have practice for you. Turn the page. Number 1 on the back. Go.